So our lesson today is on expected frequency. Expected frequency is the number of times that a particular event should occur. This is quite different to last lesson's topic on relative frequency, on what actually did happen. Alright, so expected frequency is just a theoretical probability in terms of what should be happening if you do an event X amount of times. So what we're going to do is look at an example. We are going to toss two coins 120 times. Now, if we actually toss two coins 120 times, our results will be quite different to what actually should happen. All right. What we know should happen is that the probability of getting two heads is 1 in 4. The probability of getting a heads first and then a tails is 1 in 4. The probability of getting a tails and then a heads is 1 in 4. And the probability of getting a tails and then a tails is also 1 in 4. Now, we're going to use our formula for this question. So the formula tells us that the expected frequency is the number of times the experiment is repeated multiplied by the probability of the event. So what we're going to do is we're going to do 120 because that's how many times the experiment was repeated, times by 1 in 4. And that gives us 30. So we're expecting that 30 of our 120 coin tosses of two coins gives us two heads. When we're also working out the expected frequency for a heads and a tail, now here in this example, our heads and a tail is 1 in 4, but here in this example, the tails and a head is also 1 in 4. So what we're going to do is we're going to add those probabilities together, all right? 1 on 4 times 1 on plus, and then we realize that a quarter plus a quarter is a half, so that's going to equal the same as 120 times a half, and you should know that both of these outcomes equals 60. So if we are tossing a coin 120 times, we should expect 60 of them to be a heads and a tail, because this doesn't necessarily say in a heads and a tail order. Right? If it was in a heads and a tail in that order, then it would be 30, but because the question isn't specific, we know that the answer is 60. Now, our next question is talking about Amira being a goal shooter for her netball team. Now, what we know is, at the moment, the probability she scores a goal is 88%. Alright, so if she shoots 100 times, 88% of those times will be a goal. But more importantly, we also know that she attempts 225. So, using our formula from the previous page, our expected frequency is the number of times the experiment is repeated. In this example, it's 225, multiplied by her probability, which is 88 over 100, or 88%. Doesn't matter which way you really type in the calculator. And so we're going to then do 225 times 88%, and that gives us 198. So she's expecting to score 198. Now, how we're going to solve our second problem is slightly different because we know something called complementary events. The complement of an event is the event not happening. So if we were looking at how many she would have scored, the complement of that is how many she had missed. So far, we know that she had 225 attempts on goal. She had theoretically made 198. So how many is left over is the 27 goals that she would have been expected to miss. Now, our very last example is talking about a dice, all right? Rolling a dice 480 times and recording the results. So, first of all, the probability in rolling a 4 out of a dice is 1 in 6. After we've worked that out, what we can do is our number of experiments multiplied by our probability will give us how many 4s are expected. So we can do the same thing with C and D. All right, so the probability of throwing an odd number, that there are 3 odd numbers on a dice, 1, 3, and 5, and so we're going to do 3 over 6, that's the probability, and then we also do 480 times 3 over 6, and that gives us 240. So we're expecting to roll 240 odd numbers in total. Alright, the probability of throwing a number greater than 2, so the probability of greater than 2. That actually means less than, but don't worry about that. So there are 4 numbers that are greater than 2, so our probability is going to be 4 and 6. When we do 480 times 4 on 6, we end up with 320. And for our last number, the probability of rolling a number divisible by 3, numbers that are divisible by 3 is 3 and 6, so there's 2 of them, 2 out of 6. And so our final example here is going to be 480 times 2 over 6, which equals to 160. And that's how we do this example down there.